Hey everybody, Mr. Morel here. We're going to keep talking about these arithmetic sequences, but this time we're going to write a different kind of a function for them. In the past we were writing a function that would take us, we could know its position number, and we could plug it into this function and it would tell us what the number should be in the sequence. This time it's going to be a little bit different. We're going to have to write these functions that rely on knowing the number before it. It's called a recursive function. In fact, that's the answer to question 1. A recursive function is a function that helps you find a specific term in a sequence by knowing the term before it. And I know that seems kind of crazy, and it's like, why would you use that in real life? And truthfully, this is a big computer programming aspect. When people write computer programs, they often depend on the information that comes before. And so this is just kind of my way of teaching you how to write something that you're, in math terms, that you're thinking about. Because truth is that when you see a sequence of numbers, you usually look for a pattern, and that pattern is a recursive function. It's the way that you see the pattern. It's what you're thinking in your mind. And so I just wanted to take I didn't want to. The state of Utah and the country wants you to be able to write these thoughts in mathematical language. So, it's usually very helpful to have a verbal description as we write things like that. So, when I look at this example, let's talk about this example here. If I was to describe that sequence to somebody, there's two parts that I would need to tell them. I would say, hey, your first number is -4. So that's going to be our first part of our verbal description, because that's an important thing too. And then the way that we would write that, you guys are pretty familiar with this at this point, as I would say, hey, f of 1 equals -4. That means that the first number is -4. Okay, now let's talk about the other thing here. I know that I'm adding 2 every time in this sequence. Adds 2 every time. So we started at -4 and added 2 every time. There's this really crazy way to write that. Basically, it's like this. F of x, that means to get a number that's going to equal f of x minus 1. That means look at the number before it and then add 2. So, I know that's confusing. Excuse me, but when we write recursive functions, let me show you what stuff stays the same every time. We will always, every time, be writing this stuff over and over and over. And then we'll just need to fill in what the first number is and what the pattern is. So let me go ahead and help you out here. So, number 2. Notice here that the first number is 2, and it said that right here. And the way we would write that is f of 1 equals 2. That means that the first number in the sequence is 2. Then, to get to the next number, we're going to subtract 2 every time. Or you could say that we're adding -2. Either way is true. So to subtract 2 every time. So what that means is to get a new number in the sequence, look at the number before it, and subtract 2. Alright, so for question 3, the first number is 1. So the way we write that is f of 1 equals 1. Then to get my next number, I'm going to add 3 every time. So the way that we write that is f of x equals f of x minus 1 plus 3. Just like that. And I don't know that I want to do it in this video specifically. We'll see how things play out. I would show you why these are written the way that they are. I know I'm talking about it in class. I just don't know if I have space in the video. We'll see. I'll feel out my feelers. Oh my gosh, I just erased stuff I didn't want to erase. Okay, let me erase this stuff here. Okay, so here I want to say that the first number is -4. And the way that we write that is f of 1 equals -4. Then to move to my next number and the next one and the next one, we're adding 4 every time. So the way that I write that is f of x equals f of x minus 1 plus 4. Just like that. Okay, now for level 2, I'm going to give you a pattern, and your job is to kind of write all of these different things with that pattern. So, hold on. Okay, so here we have a table. You can imagine this is like a Thanksgiving dinner or Christmas dinner or something like that. And our sequence is going to be the number of people around the table. So if we had one table, we would be able to fit 3 people. If we had 2 tables, we would be able to fit 4 people. With 3 tables, we'd be able to fit 5. And with 4 tables, I'm guessing we'd be able to fit 6. It seems like a reasonable guess to me. So that'd be really easy to make that into a table. Get it? I didn't even do that on purpose. 6, 7, just like that. Now let's write a verbal description. This sequence starts at 3, and we add 1 every time. You can write that out. It's hard for me to write that. And I just said, hey, we're adding 1 every time. That's going to be our constant difference. The recursive function, okay, it starts with 1. The first number is 1. Oh no, the first number is 3. And then to get a new number, I'm going to take the number before it and add 1. Now the explicit function, that's what we talked about in our last video. That's going to be f of x equals blank x plus blank. The constant difference is going to go right here. And the 0th number, if there were 0 tables, it's kind of dumb to think, but there would be 2 dots. So 1x plus 2. So that's pretty neat. Alright, let's go on to the next page. Here, we've just kind of got a bunch of practices for you. Why don't I go ahead and practice with you number 7. So number 7, I just read the sequence in my brain. The first number is -5. And then to get to the next number, oh, it looks like we're adding 1, but be careful. These numbers are becoming more negative. So to get a new number in the sequence, you're going to look at the number before it and subtract 1. The way that we would write that as an explicit function, f of x equals blank x plus blank. We're going to have our constant difference right here, -1. And our 0th number, the number that would come before -5, would be a -4. So that would go right there. Alright, why don't I go ahead and help you, I'll help you get started on graph 9. So remember, these dots are just representing where they, like the x number represents their placement in the sequence. So that's our first number, second number, third number, and fourth number, and so on. And the height that they are on the graph, that tells us what their value is. So here, our first number is -4. Our next value is a 1. Wait, oh, I done goofed. Our first one is a -3. It's just hard for me to see on here. Then a 1, then a 5. And then we can imagine, it looks like we're adding 4 every time, that the next number would be a 9. So that's the sequence. So again, you're just looking at how tall the dots are and making sure that you talk about the first dot first, and then the second dot, and the third dot, fourth dot, and fifth dot. That's going to be your sequence order number. Alright, and then again, that's level 4. I give you some information, and your job is to fill out the rest. It takes a little bit of tricky thinking, but you guys are pretty smart. So I have faith in you. Okay, good luck. I will see you a little bit later.